Right, moving on to the next question. The question says that all the logic gates shown in the figure has a propagation delay of 20 nanoseconds. So logic gates has a propagation delay of 20 nanoseconds, and before t some other inputs are given. The inputs A and C are 0 and B is equals to 1 until time t is equals to 0. At a time t is equals to 0, they flip all the inputs. So input A and C will become 1 and B becomes 0. Okay, and remain in that particular state for after that, right? For t greater than equal to 0, what will be output z is equal to 0 for how many duration? So the best way to solve these type of question is by using timing diagrams. So this particular operation is and, okay, this is not, so I am writing here this as x and this output as y output, right? Now this will take 20 nanosecond, this will also take 20 nanosecond, this will also take 20 nanoseconds to operate, right? Now our input A was equals to 0 before and was equals to 1 after t is equals to 0, right? This is what the question says. Now and input B was equal to 1 and after t is equals to 0 it becomes 0, right? This is what it says. Now this x, what will happen to, this is your A, this is B, what will happen to x after how much time? X will we will get the output x. So this is also not gate. Not gate is doing what? Whatever input B is getting, like whatever input B is behaving, however it is behaving, it will give the complement of B, right? But after 20 nanoseconds, so suppose this is 20 nanosecond, right? This is 20 nanoseconds. So B was equals to, for this entire time, B was equals to 1. So it will be, this is 1, this is 0, right? So it will be 0, right? And for this particular time, it became 0, but it will behave like 0 only. Why? Because it will start giving the output after 20 nanosecond. After 20 nanosecond, it will flip. Clear? After 20 nanosecond, it will start giving invert of B, X. Similarly, Y. So Y is doing AND of A and B, right? Y is doing AND of A and B. So after how much time it will start giving out the output? This is 40 nanoseconds, right? So it will performing the AND operation simultaneously and it will give the final output after 40 nanoseconds. Let me write C also before using this. Or let's just write out output y only, the AND output, right? So it will be multiplication of A and this x, or you can say this is nothing but B bar. So this multiplied by this till t is equals to 0. 0 multiplied by 0 will be 0 only, right? This multiplied by this, 1 multiplied by 0, this will remain 0 only, okay? 1 multiplied by 1, it will become 1, but it is not operational in this particular interval, right? It will be operational after 40 seconds, so it will be 0. But after 40 seconds, it will start giving out the outputs. So it will become 1 after 40 seconds. So before it, it will be 0. After this, it will give 1. Similarly, C, last input are C input. Initially, it was 0. And finally it will become 1. So initially it will be 0 and finally after t is equals to 0 it will become 1. So our final output, that is equals to z. So z is what? Z is XOR. XOR is happening, right? So XOR is happening. So XOR is happening between the output this y and this. So these XOR are happening and giving the final result as Z, right? So what is Y XOR C? What's the table for XOR? Let me write it here. So 0, 0 is 0, 0, 1 is 1, 1, 1 is 0. So this is the truth table for XOR. So this is what? This is 0 and 0. So 0, 0 will 0. 0 and 1. This will be 1, but when? After 20 nanosecond. This will start, but after this is started at t is equals to 0 only. Okay, this is starting at t is equals to 0, but this output we are getting after 20 seconds. So after 20 seconds, it will start giving the output 1. This is again is what? 0 and 1. This is again 0 and 1 till 60 seconds. But after this, what's happening? This is 1 and this is also 1. So it will again become 0. So 0, 1, 0. So they are asking what will be the amount of time when z will be equal to 1. Right. So what will be the amount of time? So till this time interval, z was equals to 1. So this is what? 40 nanoseconds. 40 nanoseconds. Right. By this way, we can easily calculate the amount of time. Otherwise, if we start spending time here, we have to like draw the timing of each and every 20 seconds interval. This is the better way, graphical way, in which we can clearly see the amount of time z was equals to 0 and z was equals to 1. Clear? Next question. Okay, the question says that in the circuit shown, if C is equals to 0, the expression for Y. We have to find out the expression for Y. Right, this is what we can directly write it. This is C bar. This is what? This is OR NOR gate. A plus B bar. This is A and B. This is A plus B bar plus C. This is A plus B bar plus C plus AB. And finally, all these inputs are applied to NAND. So Y expression we can write as A plus B bar plus C plus AB into C bar whole bar. Let's just open this bar. So it will be A plus B bar plus C plus AB bar dot C bar plus C bar bar, because dot will be converted to plus. Okay, now let's just apply it here, De Morgan's here. We will see it will become A plus B bar bar dot C bar dot AB bar plus C, right? It's nothing but A plus B dot C bar dot AB bar plus C. Now they are saying that C is equals to 0. We can apply C is equals to 0. This will become 0. This will become 1. So it will be A plus B dot AB bar. So it will be A plus B A bar plus B bar. This is nothing but POS form of A XOR B. A XOR B. This is what you can write. A XOR B is AB bar plus A bar B. Right? Okay, moving on to the next question. Next question says that again similar kind of question. In this question, 3 gates are given and you are asked to find out the final result, that is F. Right, final output F. 2 gates XOR is given, XNOR is given, and finally AND gate is given, and they are asking you to find out this value F. So let me write this as A and this as B. So what is this A? A is XOR Y. What is B? B is A XOR Z. So A is nothing but X XOR Y X NOR. Sorry, this is X NOR gate. So this is X NOR A X NOR Z, right? So this is like this. And now finally A F is AB. That means we can multiply them. So that is A X NOR Y X X NOR Y like this. So it will be, let's just open it. So let's just open this. So this will be X X NOR Y dot Z plus X XOR Y bar dot Z bar. This is how we open NOR. Suppose if input of X NOR are A and B, so how we can write the expression? So it is A, B, A bar, B bar. I have written it in the first slide, right? So let's just open it. So that will be A is nothing but X XOR Y. If I open this bracket, so this X XOR Y will be multiplied to X XOR Y only. So I have told you A into A is equals to 1 in while writing Boolean expressions. So this will become 1 dot Z plus this is what? A into A bar, right? Basically this is what, if you suppose this is A, so this is nothing but A bar only. So this A into A bar will be equal to 0. So this will become, whole will become 0. Now if we open this, so this is X bar Y plus X Y bar Z. If you open this, that will be X Y Z plus X Y bar Z. Which option is satisfying this? Option A is satisfying the result. Here, like we have to follow the same way, De Morgan, and we can easily calculate the Boolean expressions, the simplified ones, by using any complex Boolean complex variables are given, right? Doesn't matter, only similar kind of way, and that comes with practice very easily. Okay. Moving on to the next question. A bulb in a staircase has two switches, one switch being at ground floor and another switch being at first floor. Right. The bulb can be turned on and also can be turned off by any of the switches irrespective of the state of the switch. Right. The logic of the switching of the bulb resembles. So this is the question which they can easily ask in any of the interviews if you are going for any tech firm, because this is somewhat of a logical question, right? This does not have any bigger expression to solve. You can easily apply your logics behind these questions. So what the question is saying, that there are two floors, ground and first. Suppose I am saying that I am at ground floor and I am saying that 1 means on and 0 means off. Suppose I am saying that I am at ground floor and I turned on the switch, and I need now another person at the first floor, he need to switch off the so this logic should apply, that this logic should give result as 1, means this should be a logic behind the circuiting. Also, if it is, I have turned it off from ground floor, I can also turn it on from the first floor. This situation also should be true. These both of the situation should be true. If you write it like on and you can turn it off at first floor, similarly you can turn it off and turn it on from the first floor. Both the situation should be true. So which of the logical true table which can be defined from this? right? And no other option, right? Off, not true, on, not true. Because if it is off at ground level, you cannot off it again, right? And if it is on at ground floor, you cannot off it again or on it again on the first floor. You have to do the other opposite operation, right? In order to do the opposite operation, which of the logic expression should be best? This we can get from two operations, right? If I write the OR table, so OR table, but this here is wrong, because if my ground floor switch is on, the first floor switch, I can use it to off the switch, off the bulb. So this is wrong. So if I now another gate is XOR. Now this is best. So XOR is the gate which we will be using for these kind of switching, right? These questions are like very logical questions. They can trick you, but basic staircase basic staircase logics are XOR logics only, right? Because on staircase we can like a staircase bulb or light or fan, etc., any appliance is present in between first and ground floor, right? So switching should be provided on the first floor and ground floor, so it should be in this type of level, and I can control it from both the levels, right? So XOR gate is the best gate to implement these kind of switching. Okay, moving on to the next question. Okay, next question says that the output Y, again it is they have given you the output Y in the circuit is always 1. Okay, this is a little different, but again we have to solve this logical expression only by using logic gates, whatever expression we are getting. So they are asking 2 or more input are 0, 2 or more input are 1, odd number of input are 0, odd number of. So let's just see which of the options satisfies. So this is what? This is NAND. This is PQ bar. This is also NAND. This is QR bar. This is also NAND. This is PR bar. Right. Now this is NAND of these two. This is PQ bar dot QR bar whole bar. Now this is not of, so this gate is nothing but NOT gate. Whatever input we are giving here, the output will be X bar. Okay, so the bar was already there, so it will remove the bar. It will be PQ bar dot QR bar, and the final output is NAND of all the three. So PQ bar dot QR bar dot PR bar whole bar. So if you solve this, this is easy. PQ right. So this will be PQ plus QR plus PR. Right. If we are complementing all of the three expression, these dot will become plus. Basically, AND operation will reverse into OR operation, and these bars will be applied individually to them, right? And after bar is equal to the original number only, original expression only. So PQ bar and bar will give you PQ only, right? So PQ plus QR plus PR will be the expression. So if you solve it, now according to option says that 2 or more input of PQ should be equal to 0. No, if you put P and q is equals to 0, this expression you won't be able to get, right? So yeah, you cannot get it if you put 2 or more input p, q, r equal to 1. Yes, yes. So you have to put more than 2 inputs or 2 inputs in order to make this true. So option B is correct because they are in OR. They are in OR. So if you want to generate this expression and expression, so you have to give it 1 1 in order to make it true, right? So 1 1, at least you get 1, so that the total, if it is 0 0 also, so it will be 1, right? So at least 2 you have to make at as a 1 input, and other will manage accordingly, right? Also, if q is equals to 1, so that will also become 1, so this will also become 1, it will total will give a true expression. Okay, moving on to the next question. Okay, for the output f to be equal to 1, the logic circuit shown, the input combination should be. So they are saying that what will the input combination, A, B, C are 3 inputs to this, and they are asking you to find out the input combination for that f is equals to 1. Now f is what? 3 input XNOR gate. Now there is very special things about XNOR and XOR gates. So XNOR gate is basically it represents, it is 1 for, or you can say it is true for even number of ones. So it is 3 input. So basically when if a number of ones are even, then it will be 1. If I draw the truth table, so 0 0 0, so number of ones are even. So here it is odd, here it is odd, here it is even, here it is odd. Wait. I think I get lost. Okay. So this is even, this is odd, this is even, and this is odd. So basically these 4 outputs will be equal to 1, right? So it represents the even number of ones. Okay, even if you make the 4 bit, so 4 bit it will have the last number will be 1 1 1 1, so that will become 1. So this way it is true for even number of ones. And similarly, if we talk about XOR gate, it is true for odd number of ones. Okay, very important thing to remember, very frequently asked question. Okay, so it is XNOR gate represents the even number of ones and XOR gate represent the odd numbers of 1, right? So now in order to make this 1, so this is what? The above one is XOR, this gate number 1 is XOR, gate number 2 is XNOR. So they will always be opposite to each other. If it is 0, it will be 1. If it is 1, it will be 0. Always. Right? To either of, I can get 1 from either of them. Right? So I cannot always get, there will be no case that it will be giving 1 and it will also be giving 1, because they are complement gates. Right? So C should be 1 in one of the case in order to make this function f is equals to 1, right? So which option is correct? This is C is equals to 0, C is equals to 0, C is equals to 0. This will be correct. Had C is equals to 1, if A and B are 0, so if these two are 0, so XOR gate will give you 0 0 and this will give you 1. So 2 inputs will be 1. So here even number of ones are there. Even number of ones. The output will become 1. Clear? Okay, moving on to the next question. Next question says that you have to match the following. Okay, I'll start from 1. P. P is what? It is a NOR gate. There is one change here in this question. This is this is not XOR. This is OR only. Right. So this is NOR gate. So NOR gate, it is given as A plus B whole bar. So if you solve it, it will give you A bar, B bar. So what kind of input this is? So this is A bar and this is B bar and this is AND. So A bar, B bar. So P is 4. P is 4. Second one is NAND. AB bar. So it is A bar plus B bar. So you can see that this NOR gate is equal to inverted input AND gate, right? I have told you this before. And this NAND gate is equal to inverted input OR gate. So where it is inverted input OR gate? So this is inverted input OR gate. So this is A bar, B bar. So output will be A bar plus B bar. So Q will be equal to 2. Now moving on to the next one. So R is XOR gate only. XOR is AB bar plus A bar B. So let's just see which of the following from 1 and 3, which will be the which will satisfy XOR. If we try from 1, so it will be A, B, this is AB. So this is XOR only. So AB bar bar plus A bar B bar, right? So this is what? AB plus A bar B. This is nothing but XNOR gate. So XNOR gate is this. So S is equals to 1. Let's just solve for 3 also. So this is A, this is B, right? So this is A bar B plus A bar bar B bar. So this will be A. So this is what? XOR gate. So XOR gate is R. R is equals to 3. Which of the option satisfies? So this will satisfy. Right? Option D will satisfy. Moving on to the next question. So next question says that which of the following Boolean expression correctly represent the relation between P, Q, R and M1? We have to again solve it, right? We'll solve it with a similar way which we by which we are solving it. So this is what? Let's just mark some output, some easier output here only in order to make the expression simpler. Right? So PQ bar. So this is what? This is a P plus Q. This is multiplication of these two, and finally this is XORing. So this is Z is PQ plus P plus Q, and this is finally XOR with R. Let's just write it. PQ bar multiplied by P plus Q, okay, XOR with R. Let's just solve this. So this will give you what? P plus Q bar bar P plus Q. Okay. So this is what? This is PUS form of XOR gate only. So we can write that P XOR Q XOR R. So this is P XOR Q XOR R. So M1 will be P XOR Q XOR R. So this will be the correct answer. Okay, so that was all for today's class. I think we have discussed 15 number of questions, in which we have discussed some bigger expression questions, and we have solved so many of Boolean expressions in these slides. And all the gates, all the types of gate questions are covered, logic gates questions are covered, and we solved Boolean expressions also. So this was a quite fruitful class for logic gates expression, in which we have discussed so many gate questions. I have represented, these are the gate questions. The gate here is here. As I have told you, gate questions are some very good level questions in order to prepare for any type of entrance examination or any type of interview if you want to crack, right? So these are the best examples which were there in front of you. I hope you get them all, and all the best for your career, and thank you.